So in this next section, we've probably got the most things that we've got to unpack with hyperbolas. Now, up here you see a diagram of hyperbolas. It's not the most perfect diagram ever made, but it'll do for what we're looking for. And you can see that there's just a lot of lines going everywhere on here. So let's start with the hyperbolas themselves. Hyperbolas are made up of what we call branches. So you're going to have a branch here, and then you're going to have a second branch over here. Now, each branch is going to have a vertex, and that vertex you can see on this one is here, and on this one is here. Now, because the hyperbolas are opening up to the left and the right, we're going to call these horizontal hyperbolas. The next thing that we're going to look at is the fact that we've got a focus here. Our first focus is there, and our second focus is there. Now, what we're going to do with these, the focus is what makes a hyperbola. Just kind of like when we worked with parabolas, and we had a focus for a parabola, and there was a relationship between the focus, the parabola, and the directrix. Well, there's going to be a relationship between the focus, the first branch, and also the second branch. So the way that this works is this. If we take the length from the focus to a point on this hyperbola, and then we take the distance or the length from this focus to the same point on the other hyperbola, what we're going to do is we're going to subtract those distances. So I've marked this as x and this one as w. So what we're going to do is this is actually going to be x minus w, and that's going to be equal to k. And so you can see that we're going to get a value of k for the difference between those distances. Now, if we come over to the second focus and we go to that same point that we drew on this hyperbola, and we call that z, and then we draw a line to the other point on the other hyperbola, we're going to call that line y. Now, when we take y minus z, or the absolute value of y minus z, we're also going to get k. So the relationship between the foci is that whichever point you pick on the asymptote, the difference of those distances is always going to be the same thing. So that's where we get hyperbolas from. Now, these hyperbolas are going to follow asymptotes. Now, remember that an asymptote is simply a line that cannot be touched or a line that cannot be crossed. So our asymptotes are on here, are indicated in orange. And you can see that the hyperbolas are going to run based on where those asymptotes are. Now, the last thing that we've got on here is we can draw a rectangle basically running from due north and due south from the vertex, due north and due south from the vertex to the asymptotes. And then all of those points together are going to create a rectangle. Now, what we've got here is the value b. And we're going to use that value b for when we're working out some problems, when we're working out some things in later problems. Going back to the vertex is going to be the point plus or minus a, and then 0 if it's a horizontal asymptote, and 0 plus or minus a if it's a vertical asymptote. The focus is going to be plus or minus c and 0, again for a horizontal asymptote. And then if we've got a vertical asymptote, it's going to be 0 plus or minus c. And this is always going to be when c squared is equal to a squared plus b squared. Finally, our asymptote is going to be the value y equals plus or minus b over a, and then x for our equation for a, again for an asymptote on a horizontal hyperbola. If this were a vertical hyperbola, then it would be a over plus or minus b. So now that we've seen what hyperbolas look like, we're going to take a look at a problem and see if we can actually come up with an equation for one. And it's really a little bit more straightforward than what you would think based on what we just saw in the last clip. If we are looking for the equation for a horizontal hyperbola, you can see that it's going to look an awful lot like the equation that we used for an ellipse. But what we're going to do is, instead of having a plus in between, we're going to use a minus. So we've got x squared over a squared minus y squared over b squared equals 1. And then don't forget that we're also going to be using c squared equals a squared plus b squared in this process. Now, the vertical hyperbola, you remember that with an ellipse, we switched the denominators. But when we're talking about hyperbolas, we're actually going to switch the numerators this time. So it's going to be y squared over a squared minus x squared over b squared is equal to 1. Now, the asymptotes we'll get to a little bit later in the next part of the problem. So we've been given information for a horizontal hyperbola with a center at 0, 0, vertices at plus or minus 4, 0, and one focus at 5, 0. So you can see that I've gone ahead and plotted this on a coordinate plane. Now, what we've got is our vertices again are at -4 and +4, and our focus is at 5. Remember that the vertices are plus or minus A, and the focus, or the foci, are at plus or minus C. So what we're going to be looking for is the length of, or half the length of what is called the conjugate axis. So the conjugate axis is the one that is running in between the foci. The transverse axis runs to them. Okay, so one runs from one to the other one, and the conjugate axis runs between them, halfway between them. We need to find this value right here, which is b. But what's nice is we already know that this is the value of a, and this is the value of c. So all we've got to do is just plug this into our Pythagorean theorem and figure out what it is. So remember that we're dealing with c squared equals a squared plus b squared. And so we're going to plug in 5 for c. So 5 squared equals 4 for a, 4 squared plus b squared. Now, hopefully you remember this from geometry, Pythagorean triples. We have a 3, 4, 5 right here. 5 squared equals 4 squared plus 3 squared. If you don't remember this, you can go ahead and work it out. You're going to get 25 equals 16 plus b squared. So you're going to slide this 16 over, and that's going to leave us with 9 is equal to b squared. And so b is going to be equal to plus or minus 3. So we know that the length of half of the conjugate axis is 3, and the entire conjugate axis is going to be 6. We only care, though, about the 3. So what we're going to do is we're going to choose whichever equation we need. And since all of our foci and all of our vertices are on the x-axis, that tells us that we've got a horizontal hyperbola. So we want to use x squared over a squared. Now a, remember, is going to be 4. So we get x squared over 4 squared, and then minus y squared over 3 squared is equal to 1. So our equation is going to be x squared over 16 minus y squared over 9 is equal to 1. And that's how you're going to find the equation for a horizontal hyperbola. The next thing that we're going to do is go ahead and sketch out our hyperbolas. To be able to do that, we need our asymptotes. So go back to all the information that we've got so far. And we know that a is equal to 4, b is going to be equal to 3, and c is going to be equal to 5. Now really, to sketch out our asymptotes, all we need are a and b. And you can see that the formula that we've got for horizontal hyperbola's asymptotes is y equals plus or minus b over a. So what this tells us is we're going to have y is equal to plus or minus 3/4 x. Pretty simple. We know that we've got a y-intercept of 0, and then we've got, we're going to go up 3 units. So up 1, 2, 3, and then right 4 units. So we're going to go right there, and then down 1, 2, 3, and then right 4 units. We're also going to go left 4 units and left 4 units there. So now we can draw in our asymptotes. And once we've got those drawn in, we're just going to go ahead and sketch out hyperbolas. We're not going to do all the math on this for right now. We're just going to sketch them out, and you're going to see that your hyperbolas are going to end up looking like this here. And remember that your hyperbolas cannot touch your asymptotes and they cannot cross your asymptotes.